Hey everybody. So I've been absent for a while, but I wanted to create a series on how to use this really fantastic plugin for our Markdown called Papaja, which stands for Preparing APA Journal Articles. And so what this does is it allows me to use our Markdown to create an entire APA styled manuscript. And the nice thing is, even if you aren't writing APA, a lot of this is manipulatable so that you can maybe use a different style sheet to write in Harvard style. I wanted to give a quick example of what one looked like that we have posted on our Open Science website that you can download the entire manuscript and create it yourself. So this does require that you have the newest version of RStudio. And the first time that you learn how to knit something, you will also be asked to install several packages, including knit-r. Papaja uses LaTeX in the background, or LaTeX, I'm never quite sure which way it's pronounced, which you will need to download the full version of to knit to PDF. If you're going to always knit to Word, I don't think you need it, but PDFs work a lot better and they tend to look like the appropriate style than the kind of workarounds you have to do to make Word happen. So if you have this installed, which I'll show you how to do in a second, it's very easy to create a blank APA document. So you click on New Document, R Markdown. You can pick from template once you have Papaja installed, and it's actually one of the first options. There's also pre-registration options that you can use if you want to use the pre-registration challenge, for example, on the Center for Open Science's website. Click OK, and it will auto-populate with some of the main things that you need to get started. And so a later part of the series will cover bibliographies and how those work. Today we're going to mainly focus on doing a couple of little things on how to get numbers out of our chunks. So this does assume that you're at least a little familiar with R and you're trying to transition to writing an entire document in Markdown. And so it kind of creates you just a blank shell that you can use. And then here's an example of what one looks like filled in. And so the great thing about using Papaja and Markdown is that we can take all of our code and put it within the document. So here's our introduction. All of these purple components, pinky purple components here, are references. So I don't have to remember how to reference properly. I can get it to do it for me. In this particular paper, we used a lot of Greek symbols, so we can get it to write the symbol for us. And then there's a lot of code in here. So I'll give you the quick and dirty scroll of how much code this is. And what it's going to do is create all of these, run all of this code. Sometimes it'll run, sometimes it won't, depends on how I set it up. And it'll also fill in the numbers for me. So it's going to take this and create pictures out of the data. So here's an example of what a picture chunk looks like. And we'll cover that more in a later video. And actually create the reference page and all of the referencing in the appropriate way. So the ultimate goal here is to be able to write this entire manuscript, be able to click knit, and have it make everything for you. Depending on how much code and how long the code takes to run is how long it takes to knit. So this one's actually pretty quick. You have a couple of documents that the code is quite complex and it takes 20 minutes to run. So it'll just kind of depend on what you're having it do for you. Oh, and this made this a Word document because apparently I forgot to change it back. So I can actually knit this to Word. One of the biggest problems with knitting to Word is that it's not perfectly formatted, kind of like due to the limitations of how this was written. And so one of the big things is it puts the figures in line, and then once you get down here, it formats them kind of the opposite way, and that's all on Papaja's GitHub site. But I can also tell it, if I do it correctly, to do everything in PDF. I highly recommend the PDF option, although installing LaTeX is kind of a pain. If you don't have it already installed, it's a very big file. But this version tends to look like a finished manuscript. So we'll give that a second to knit so that you can see what it looks like. So if you're going to get any errors, it's going to come up over here in the Markdown area. And unfortunately, I don't know that the errors are super helpful. So if you're looking for a misplaced $sign, sometimes it can be difficult to find. But what it does is it creates the entire manuscript for you, complete with references, appropriately edit'd and in alphabetical order when it's appropriate. And then a reference page at the end. You also can, once you get past the intro here, our super long intro, create mathematical formulas. And then once we get into the results, it will pull the numbers for you. So this was all code in there. So if I change something because a reviewer asked me to fix a problem, now this will automatically change. Clearly I'll need to make sure I still interpret those numbers correctly, but it's nice because I don't have to retype all those numbers myself. Then lastly, it creates appropriate looking references for you. I'll do a whole series on how to do this as part through Mendeley, but I imagine you can also do this with EndNote. So that's the ultimate goal of what this series of videos is going to cover, is how to create these reproducible manuscripts in Markdown using Papaja. So we're going to start with a cheat sheet that I'm giving my graduate students, but the way that you install Papaja is not a full library, so you need to make sure that you have DevTools installed. This is a regular package that you can install by clicking on Packages. Let me zoom out just a little bit. And then click Install and just start typing DevTools. Okay. I already have this package installed. Ooh, interesting typo. But DevTools allows you to connect to GitHub, which will install packages that are under creation. Then when you go to install Papaja, it's very similar to installing Mote, which is also on GitHub only at the moment. But you use that DevTools library, the install GitHub function, and then this is particular for Papaja. So username / function name. And so that's a package we'll use to do a lot of what we're going to do. So let me comment that out. You don't want it to have it install when you hit knit because it freaks out. So we're going to load that Papaja library and load our Mote library, which I have a video on how to install that one, but it's very similar to this one, which our lab has written. So we've got our chunks here that we're using, and we want to format that work in, let's say, APA style. So Papaja has lots of like APA formatting options, including tables, which is really handy when you get these gnarly tables that you need to make. And then in the Mote library, I added a little function called APA that allows me to format my decibels in the appropriate way. And so let's say I want to create some descriptives. And so I just made a fake Ttest to help my students learn this. So I'm going to use the air quality data set that's in the background of R. It's one of the base R's data sets. And so I'm loading August and September. So in August and September here in Missouri, it can be ungodly hot, and it really is. So let's pretend we're going to compare if there's a difference in temperature between August and September. And so I'm going to use my tapply function to calculate the mean, standard deviation, and in values for those months. Now at the moment, nothing is printing out because I haven't told it to show me those values. Okay. So over here, I'm just going to type that. So now I've got the temperature in August is 84, the temperature in September is 77, the standard deviation for both of those, and then the sample size, which is the number of days. Okay. But I want to save them up here so that I can use them later. Okay. And so when I was teaching my students how to do effect sizes, calculate effect sizes, we talked about how you can take those mean numbers and pull only one number. So if I have I want just August, I would do mean and give me the first option. So this one here. And so that indicates the first mean from tapply, whereas M2 here is the second mean. And so we can use that to now print outside of a chunk. So the whole goal is here to run the things in the chunks and then print outside the chunk. And so big chunks that turn gray get 3 of these little signs, where little chunks only get 1. I have this commented out so it will actually print out when you hit knit. What this does is it just says actually type out that little symbol. You aren't normally going to do this. This is just so that when you knit this document it doesn't give you an error. So I've got one little chunk. I'm telling it it's R to run R, which is the same thing that this does up here. And then I'm going to tell it to print out mean 1. And then now print out mean 2. You don't have to put them on separate lines. I just did this so you could see. So I'm going to hit knit real quick, just so you can see what that looks like. This is going to print to Word. Okay. Now I do have it set up where it currently is going to print the chunks for us, but we can turn that off. And see, now it's printed my means for me. Now these means are not formatted very well. So when you knit the document, it will actually print out the entire number, all 16 decimal places if it has them. So we don't want that. Instead, what we want to do is actually print them with maybe 2 decimal places. So the APA function allows us to clean up our code, and that's in the mote library. Papaja might have a function like this, but I haven't found it. It has functions that we'll use down here for Ttest that are really handy. So the APA function requires 3 arguments, the number or a vector of numbers. So you can actually run this across an entire table to change all of your numbers at once. The number of decimal places that you want, so 2, 3, 8. T to include the leading 0 on a number, so a number that can go over 1 in APA style needs a leading 0 if it's less than 1. Or false to exclude the leading 0, like p-values. Or eta squared. And so here, both of these numbers get bigger than 1, so I'm going to leave the true there. True is the default. If you leave that off, it will assume you mean true. But here, this is going to take those 2 means and format them to 2 decimal places. The nice part about that is that it changes this one from having 1 decimal to actually having 2. So this is the pretty version where you can print them out. Now I can take that and use some italicizing format to actually make this look like APA style. So the mean temperature was, and then I have my mean, but this will make it italicized by putting the little stars around it, equals, and then print out that mean. Now my standard deviation equals, print out the standard deviation, and then do that same thing again for September. So it looks kind of crazy in here, but once you put it together and actually have it knitted, it looks like you had written a very nice APA sentence. So the mean temperature for August was, here's my mean and my standard deviation, and the mean temperature for September was mean and standard deviation. The nice thing about doing this is once you get the hang of like writing code in a sentence, let's say you find an outlier and you decide to delete it, you can hit reknit and recreate this entire document without that outlier. And it will refill in these numbers for you so you don't have to retype them every single time. Now what we want to do is maybe run a t-test and see if those numbers are different. So I'm going to save my t-test output. And I've told it to print out here so you can see what it would look like. So normally what we would do is like type T, df of 59, T, here's my p-value. But what we can do instead is in the Papaja library there's this function called APA print. It works on most LM output. So anytime you use the LM function or AOV or Ttest. And what you can do is that will print out 3 different pieces. And so we kind of have to pick the one we're interested in. Okay. So $estimate is the mean change in confidence interval, and it does that for independent or dependent t. So it shows you delta M. The dollar statistic is the T and P value in an appropriate format. Or full result is both of them together. Since I have already reported both of those means, I just want the statistics. I just want T. But I could have said, give me dollar full result and reported the whole shebang at once and ignored the means. Okay. So now I can use that encode, so APA print T output, and then you just put right after that dollar statistic to get only the Ttest. So let's come back over here. Right. And so now here is that T output formatted correctly. If we're going to use that moat library, we might as well add more evidentiary value to our paper by adding effect size. So I'm going to calculate an independent T effect size, or DS, which includes the pulled standard deviation on the bottom. So that function, the way it works, I'm trying to get it to highlight, mean 1, mean 2, then SD1 and SD2, N1 and N2, and then what alpha level you're interested in. So actually, the moat library will calculate independent T for you and print that out, but I wanted to show you how APA print worked as well. So APA print will work on Ttest output. It will not, unfortunately, work on the moat library. And so let's run that. And it's mad at me because I have not upgraded to the newest R. But then I can see that my effect size is 0.94. And so if you want to know how to pull the numbers, you can just type effect over here in the console. And we have it set up such that it returns a list of every value that you entered and or that was calculated. And so it calculates D, the lower level confidence interval for D, the higher level one, the mean, standard deviation, standard error for each mean, the confidence interval for each mean separately, S pooled, S standard error pooled, degrees of freedom, and actually T down here as well. So this function gives you all of the output you would need, but I wanted to talk about APA print. So now I'm going to combine my test statistic that we learned how to print out up here with my D value. Okay. Now I'm not entirely sure if you have to have LaTeX installed for this part to work, but one thing you can do is get it to give you Greek symbols or super and subscript. And so those kinds of things will automatically be italicized. And so where that action is happening is here. So I've got the dollar signs around it, which indicate that it should be doing some LaTeX. And then D underscore gives it the subscript. And then the S here, and I have it in these curly brackets. I don't need it, but if you need more than one letter, so let's say you were going to type SD down at the bottom, you would need the curly brackets. So I always include them just so I don't forget them. So now we've told it to print out the statistic. I've just popped in a comma saying DS is. I've pulled D value with that APA print function, or the APA function from moat. Said here's my 95% confidence interval for D, and then print the D low and the D high. So we look at the knit version. What you see is the entire thing printed out in APA style. So T, P, and then here's D and its confidence interval. Okay. And then here's an example of some other Greek symbols that it will print. Now I could knit this entire document also to PDF, but if you just want to get started by using Word, this should work. The only question I have is I'm not entirely sure. I know I have LaTeX installed, so these work fine, but it may not if you don't have it installed. Now, what if I don't want to print all these blocks? So I have these printing because I'm trying to teach my students how to do this, but let's say I don't want it to print the block because you wouldn't want that in your document. The nice thing about all these blocks is they have these little setup options. So you just click on the little wheel, and I can actually tell it to show nothing and run code, which is include equals false, so don't include the block. I can tell it to show nothing and don't run the code, and that's eval equals false. So that means that it'll include the code, but it won't actually run the code. And so that's really handy if you're like wanting to show people the code that you ran to get something, but don't want to take all day to run it. So we've written several simulation papers, and we don't want to rerun the simulation because we would be here for 3 weeks. But we do want to show people what code we ran. So it says include equals false and eval equals false. So you can't see it printed out in the document, and it doesn't run, but if you open this Markdown file, you can see it. Okay. Show code and output is echo equals true. I mean, there's a couple of different options, and you can tell it to not show warnings and not show messages. So you can play with what option you'd like to see what printout version you'd like. I'm going to leave this where it shows everything. But if you look at some of our blocks, you can see that we said eval equals false and include equals false. So this block does not actually run. We just included it so people would know what we did. But then here we have a graph, and it says echo equals false. So that means don't show the code for the graph, but show me the graph. Like, I want you to be able to see the picture. And we'll get into later more on how to format graphs. Right now we're just talking about how can I take a piece of information from a chunk and print it out in the actual text of the document. And so just a quick how-to with Papaja and Moat. And then the next series of videos will cover how to make tables and pictures, as well as the formatting for references.